Where are others? So what time is the school getting over? 3:45. Okay, you can revise the topics of yesterday's class. Right? Guys, settle down fast. Listen. So what were the concepts we discussed till now? What were the concepts we discussed till now? So from the beginning, if you see, we discussed about the electrostatic potential energy. Then we understood what is electrostatic potential. Then we understood what is electrostatic potential difference. Then what is the relation between potential energy and potential difference? U is equal to Q naught into V. And we solved some few problems also. Then we saw what is the electrostatic potential due to a point charge. Then we saw for system of charges. Then for a dipole, we calculated the electrostatic potential at. We didn't start that. Huh? We didn't do that. Okay. So write down the next heading as electrostatic potential due to a dipole at axial point. So the next topic that we are going to see is electrostatic potential due to a dipole at axial point. Okay. So we have a dipole, positive and a negative charge, both of same magnitude Q, and separated by a distance of 2a, right? So they are separated by a distance of 2a, and on the axis of it, let us consider a point P here, right? We know that whenever you calculate any parameter like electric field or electrostatic potential, the distance is always measured from the center of the dipole, right? So if I take the center to be O, from the center of the dipole to this point P, I will take this distance to be R, such that the same approximation we saw in the previous chapter is applicable. R is very much greater than A, and R square minus A square is approximated to R square, right? This is what we are going to use. Now, on the axis, I've taken this point P. Our job is to find what is the potential due to this kind of a system at point P. So it's very simple. So potential at point P is equal to the potential that is generated. Let me call this as charge A and let me call this as charge B. Okay, it is going to be the potential that is generated due to the charge at A, plus the potential that is generated due to the charge at B, right? So for the charge at A, the potential is going to be KQ divided by K into Q divided by this distance. So how much is this distance going to be? This is R, this is A, and this is also A. So it is going to be R plus A. What about this distance? This distance is going to be R minus A, right? So KQ divided by R plus A plus K into minus Q divided by R minus A. So if you observe, KQ is common in both, right? So can I write this as KQ into 1 divided by R plus A minus 1 divided by R minus A, right? I've taken this minus sign outside. It is minus 1 by R minus A, right? Now I'm going to take the LCM. So it is going to be KQ multiplied with R minus A minus R plus A, the whole divided by R plus A into R minus A is R square minus A square, right? So for R square minus A square, I'll use this approximation. And in the numerator, if you see, R and R are getting cancelled. This is minus A, this is minus A. So minus A is minus 2A. So this is going to give us KQ into minus 2A, the whole divided by R square, right? So 2A multiplied with Q is going to give us the dipole moment. So minus of K into this Q into 2A, I'm replacing it with the dipole moment, the whole divided by R square. So this is going to be the value of electrostatic potential at point P, where this point P is considered to be the axial point. But R square minus A square is approximated, right? So here if you observe, minus Kp divided by R square is the value of electrostatic potential at point P, right? So if you ask me if this is the value every time, no. Value in the sense, I'm talking about the sign, I'm concentrating on the sign, right? If suppose somebody asks you what is the potential at point P, if you say minus Kp divided by R square, you will be wrong because it depends on where you're considering that point. In this scenario, we got it as negative because the point P is considered closer to the negative charge. But when you talk about this to be the axial line, you could have taken this point P on the left-hand side also. Had you taken it on the left-hand side, this answer would have been positive. So what you need to remember is the magnitude part. So depending on which side the point is being considered, you add the minus or the plus sign, right? So you calculate only on either of the sides. You don't calculate it in between because the size of the dipole itself is very small. Am I clear with this point? So here, this is going to be the value in this scenario, but the magnitude part is going to be K multiplied with P divided by R square, right? So please make a note of this. Hmm. A is negative, B is positive, no? Then you will get plus. Right? Shall I proceed to the next one? So the next one is electrostatic potential due to a dipole at equatorial point. Right? So electrostatic potential due to a dipole at equatorial point. So if you take this to be the positive sign, this to be the negative sign. So if I take the point here, which is the equatorial point, right? This is going to be the center of the dipole. So it is broken into two parts, A and A, right? So if I take these distances, if I take this to be A and this to be B, so obviously what is going to be the distance AP? It is going to be square root of R square plus A square. Then what is going to be the distance BP? That is also going to be square root of R square plus A square, where this is R. We know that the distance to any point is measured from the center of the dipole, right? So potential at point P is again going to be the potential generated due to the charge at A plus the potential due to the charge at B. So what is the potential due to the charge at A? It is going to be KQ divided by square root of R square plus A square, plus what is going to be the value of VB? It is going to be K into minus Q divided by square root of R square plus A square. If you observe, they both are equal in terms of magnitude, but opposite in terms of sign. Hence, they get cancelled. So this clearly indicates that when you take a dipole, right, at any point on the equatorial axis, the electrostatic potential is going to be a zero, right? So electrostatic potential due to a dipole at equatorial point is always a zero, unlike the electric field. Am I clear? Right. Make a note of this. The next one is we need to calculate the electrostatic potential due to a dipole, neither at the axial nor at the equatorial. We'll calculate it at some random point. Okay, so that I'll show you. So write down the heading as electrostatic potential due to a dipole at any point other than axial or equatorial. At any point other than the axial or equatorial. Did you write it? So that's there in the recording already. Okay. So listen, you have a positive charge, you have a negative charge. So if I take a point P here, which is neither along the axis nor along the equatorial, if I take this to be the center O, if this distance is R, right, then this is going to be A and this is also going to be A. Let this be Q and let this be Q. Let's say this line is making an angle theta with respect to the axis of the dipole. Okay. So this is A and this is B. Right. See, from the point A to point P, let me call the distance to be R1, and from B to P, let me call it as R2. Okay. So remember, your final answer is not supposed to be in terms of R1 or R2, rather it is supposed to be only in terms of R, because that is the distance calculated from the center of the dipole. Right. When that is the scenario, it is our job to write R1 and R2 in terms of R. Right. For that, we will be using a property from, or we'll be using a concept from a topic called as properties of triangles, which is called as cosine rule. Okay. So if you take a triangle like this, if I take this to be ABC, okay, where this ABC is not a right angle triangle, because you know the trigonometric functions are applicable only for right angle triangle, but here I have some random triangle. It can be a scalene or it can be an isosceles, we don't know, but it's not a right angle in this. If I take this angle to be A, the side opposite to A is called as small a. Similarly, take this to be B, the side opposite to B is called small b, and here if I take this to be C, this is called as small c. So if I need to define cos of angle A, right? So A is included between two hands, B and C. So how you write is, you write it as B square plus C square. That is sum of the squares of the sides, which is including the angle, minus the square of the side which is opposite to it, which is A square divided by 2 multiplied with the sides that are included. That is 2 times BC. Right. So cos A is written as B square plus C square minus A square divided by 2 times B into C. So just to understand this pattern, right, I'll tell how to write for cos B. So all you need to do is you see which two hands are including that angle. So B is included between A and C. So what you do is A square plus C square minus the opposite square divided by 2 times AC. So we are going to use the same logic here. Okay. For that, if you observe, the process is again the same. Vp is equal to VA plus VB. Right. It is going to be VA plus VB. But what is the value of VA? It is going to be KQ divided by R1 plus K into negative of Q divided by R2. So if you see here, I don't want the value of R1 and R2, rather I need the value of 1 by R1 and 1 by R2. Right. For that, I'm going to apply the cosine rule to the two triangles that I'm able to see here. So if this is theta, then this is how much? 180 minus theta. So if I take the triangle AOP, this is going to be 180 minus theta, right? This is R1, this is R, then this side is going to be A. So what is cos of 180 minus theta from this? So cos of this angle is equal to A square plus R square, or R square plus A square, minus R square divided by 2 times AR. Right. But what is cos of 180 minus theta? It is negative of cos theta because it is in the second quadrant. Right. This will be equal to R square plus A square minus R1 square divided by 2 times AR. So cross multiply this. So can I write R1 square is equal to R square plus A square plus 2 times AR cos theta? I'll tell you what I did. This R1 square, I brought it to the left. 2AR multiplied with minus cos theta is minus 2AR cos theta. If this goes to the right, it becomes plus 2AR cos theta. So what I did is I interchanged the negative values. So R1 square is equal to R square plus A square plus 2 times AR cos theta. Right. But what is R square plus A square? How is it approximated? So can I write this as R square itself? So R square plus 2 times AR cos theta is R1 square. So what I'll do is I'll take that R square outside. So when I take that R square outside, it will become 1 plus 2A divided by R cos theta, which is R1 square. Am I clear with this? But what did I tell you? I don't need R1. I need 1 by R1. So 1 by R1 square will be equal to 1 by R square into, observe what I'm going to do is, I'll write this as 1 plus 2A cos theta divided by R to the power of minus 1. Makes sense? Right. Now what I'll do is, I'll take square root on both the sides. So let me write this point alone in the next page. So what is it? It is 1 by R1 square is equal to 1 by R square into 1 plus 2A cos theta divided by R, the whole power minus 1. This is the value. So taking the square root on both the sides, I get 1 by R1 is equal to 1 by R into 1 plus 2A cos theta by R, the whole power minus half. Am I right? So listen to this carefully. According to binomial theorem, if at all you have any value like this, 1 plus x the whole power n, where the value of x is very much less than 1. If the value of x is very much less than 1, then this can be approximated to 1 plus n into x, meaning 1 is left as it is, plus is left as it is. This x is multiplied with the power. So it will become 1 plus nx. So using the same logic here, but you can ask me, how can I use the logic here? Is because we know this approximation, r is very much greater than a. So if I divide with r on both the sides, 1 is very much greater than a divided by r, meaning a by r is a value which is very much less than 1. Here if you see, a by r is acting like this x. So since this value is very small and this is also a small value, the multiplication of both will give you a smaller value, right? So 1 by R1 will be equal to 1 by R into, what should I write? 1 minus half into 2A by R cos theta. So 2 and 2 will get cancelled. So what will you be left out with? 1 by R1 will be equal to 1 by R into 1 minus A cos theta by R. Is that point clear? So if I call this as 1, for instance, right? Now see what I'm going to do is, I hope it is clear till this step. right? So if I take this to be 1, remember we came to that value by starting with cos of 180 minus theta. That is, I took this triangle. So because of cos of 180 minus theta, here you had a minus. So the final answer also you have a minus. So if I start with this value, it will be cos theta, which is going to be a positive value. So on a similar note, what will happen is from this triangle, I can relate R to R2. R is related to R2. So on a similar note, what I can do is, if we follow the same steps, then I'll get 1 by R2 is equal to, this 1 by R is same. 1 by R multiplied with 1. Instead of minus, you'll have a plus. So 1 plus A cos theta divided by R, let me call this as 2. Okay. So I need to take this 1 and 2 and substitute it in this expression. Let me call this as star. Right. I need to take 1 and 2 and substitute it in this star. Right. So what will I get? Potential at point P will be equal to, what is common there? Can you tell me? KQ is common. So what will you have inside? KQ, if you take it out, you will have 1 by R1 minus 1 by R2. You will have KQ into 1 by R1 minus 1 by R2. So potential at point P will be equal to KQ multiplied with, what is the value of 1 by R1? It is this thing. 1 by R into 1 minus A cos theta divided by R. Minus, what is the value of 1 by R2? It is 1 by R into 1 plus A cos theta, the whole divided by R. Right. So if you observe, this 1 by R is also common. I can take it out. So what will you say? You will have KQ divided by R into 1 minus A cos theta by R minus 1 minus A cos theta by R. Because minus 1 minus A cos theta by R, 1 and 1 are gone. So you'll be left out with minus 2A cos theta divided by R. So this will be KQ into minus 2A cos theta divided by R. So 2A multiplied with Q is dipole moment. So you will have the answer to be minus KP cos theta divided by R. Here also you are getting minus sign because you look at the diagram. I've taken this point closer to the negative charge. Had you taken it on the other side, you would have got the positive value. So 1 minute. So KQ, here you have an R. This R and R will get multiplied. So you will get minus KP cos theta divided by R square. Right. You understood this one, right? So here I'll write it in this gap itself. If you observe, right? When you talk about axial point, if I take the point P on the right of negative charge, what will be the value of theta? If I take this point P at this point, what will be the value of this theta? So it would have been 0. So axial point, if I substitute theta is equal to 0 by taking on the right side of the negative charge, what will the answer be? So I'll get minus Kp divided by R square. Had we taken this point P on the left hand side, then what would have been the value of theta? 180, right? So if I substitute theta is equal to 180 degrees here, what will I get? You will get Kp by R square. I told you, you will get a positive sign there. Am I clear with this? So minus Kp by R square, this is going to be Kp by R square. And what about equatorial point? So for equatorial point, theta will be 90 degrees. So if you substitute 90 there, what is going to be the value of? It will be 0. And that is what we got in the previous case. So this is like a general formula which can be used for either of the situations, right? So it starts from here. Where did you write? That's the last concept. You wrote till there. Huh? Done copying? I think most of you have already written it. No? You could see most of you have already written. You're copying now only. Right. Next slide. Huh? So let me know once you're done. Done. Everybody is done? Okay. Shall I proceed? Yeah. So next we'll see a very important topic, okay, which is called as equipotential surface and its properties, right? So here, if you see the word equi refers to same, you know what is potential already, right? So when I talk about a surface, it can either be a two-dimensional or a three-dimensional surface. So if you take a particular surface on which the potential is the same. So if you take any surface on which you take any point, if the electrostatic potential is same, then you call that kind of a surface as an equipotential surface. Am I clear with this? Right. So if you take any surface that has the same electric potential at every point on it, it's called as an equipotential surface. So the surface may be a surface of an object or a surface in space, right? And another way of defining it is, observe, another way of defining it is, if I take any 2 points, so potential of A is equal to potential of B. So if I take another point C, then this will be in such a way that it is equal to the potential of C as well. Then what will be the value of VA minus VB? Is it not 0? Similarly, VB minus VC, 0. So what can you conclude from this? Either on that surface, the potential at every point is supposed to be the same, or the potential difference between any 2 points is always a 0. So there are 2 ways to define it. A surface which has the same potential, or a surface which has a 0 potential difference. Okay. So how is the equipotential surface going to be? Right. First, we'll understand what are the properties of this equipotential surface. Right. So the first one is no work is done in moving a test charge over an equipotential surface. If at all, I take a random surface like this, and if I call it to be equipotential, it can't be in the shape. If I call it to be equipotential, for instance, okay. If I take the point A here and the point B here, now what are they saying? No work is done in moving a test charge over an equipotential surface. Meaning, if I have a test charge at point A and I'm interested to move this test charge from point A to point B, right? So we know that whenever you move a test charge across a potential difference, it is always going to get stored in the form of electrostatic potential energy. We know this formula already. V is equal to Q naught into V, where this V is not the potential, rather it is going to be the potential difference between those 2 points. Am I clear with this? Right? Or I'll write it as VAB, for instance. Means I'm moving it between A and B. So Q naught is non-zero because it's a test charge which has a finite magnitude. Now the question is, what is going to be the potential difference between the points A and B? It is going to be 0. So this Q naught multiplied with 0 is going to give us a 0. That is the reason why work done in moving a test charge on an equipotential surface is always 0, and this point is often asked. Right? So are you able to understand the logic? Yes, you can make a note of this point. Because every point has the same potential. No? See, if I take the potential of point A, let me call it as B. What is the potential of point B? That will also be according to the definition. So what will be the potential difference between point A and B? It is VA minus VB. But what is VA? V. What is VB? That is also. Okay. You need not write the last point. Copy it till. Done? Okay. This one is done. So property number 1 is no work is done in moving a test charge over an equipotential surface. Clear with this? Done? Okay. Listen. So the second property is electric field is always normal to the equipotential surface. See, suppose I take this to be the equipotential surface, right? If I take a point here and another point here, A, B, if I take the test charge to be Q naught, right? So what did the previous point tell us? It told us that the work done in moving the test charge between any 2 points is going to be 0. So work done between the motion of the test charge between A to B is going to be a 0. First point to be noted. Secondly, we know that the work done is also going to be equal to force into displacement. Or I'll write it as force into displacement into cos theta. right? Let us assume that the electric field was not normal to the surface. If I take the electric field, for instance, to be like this, okay, then this electric field can be resolved into two components, right? If I take this to be theta, for instance, then it can be resolved into two components where one is e cos theta and the other is going to be e sin theta, right? So had this e cos theta component existed, then this e cos theta would have carried the test charge along the curve. Had e cos theta existed, what will it do? It will take the test charge along the curve. So if at all the test charge had moved along the curve, then what would have happened? Then the work done by the force would have been non-zero. But is it not contradicting the statement? Right. So work done would have not been zero because of the statement. This is the implication, but it is a contradiction. So since it's a contradiction, what should happen? E cos theta component has to be zero. So electric field can't be zero. But what can be zero? Cos theta can be zero. Then what is the value of theta? So that is the reason why the electric field is supposed to be normal to the surface. Am I clear with this? Right? Clear with this? Okay. So there is one more property, but I'll explain that in the next class. Right. So any other doubt from today's class? Okay. So we need to solve problems also based on this. We'll see. So I'll update you if I'll be recording the videos. I have already put the videos. I told you, no, there were some wrong videos which were uploaded. So if you see, you would have last week you would have seen videos which were of live classes, but actually yesterday I replaced it. Which are the pre-recorded ones, like how I told you, it will be in the particular order. So if you go to the app, right, I'll show you. So inside the app, you will have chapter 1 electric charges and fields, which is this year's class of the live classes which were taken here. And you have another section which is pre-recorded. So in the pre-recorded thing, I have uploaded first the second chapter's videos also, in which you will have theory lectures, right? Once you click on that, right, you can sort it by the name here. You will have an option to sort. Click on sort and sort it by the name. You will have everything in the order. Right. So lecture 1 is about the electrostatic potential energy. Each will be less than 15 minutes. So I have done it like this so that you will not have confusion. Last week, this is what I actually dropped. I told no lecture 1 to 12. I didn't see that the wrong videos got uploaded. Okay. So this is how it is there, and equipotential surface, the same concept, but there will be screen recording alone. You can have a look at it if at all you have any doubt. By the way, these videos will also be uploaded for your reference. Clear? So if at all needed, I'll let you know, like you need to go through the videos and come also. So depending on the toughness, I'll tell you. Okay, so be ready for that. And secondly, next week, I have some rituals to be done where I have to travel, but I'll be taking class. Okay, I'll be taking it online. The only concern is just now I thought, how many of you can reach home by this time, like around 4:15 or 4:30? Everybody can reach? How much, what time, what is the time you can reach? 4:30 will work? 4:30 will work? Right. So 4:30 to 5, I'll push it by half an hour. So 4:30 to 5:30 we'll have the classes. I'll take it online. The week following it again we'll have the offline classes. So for you, the school is getting close, right? By 28th. But only thing is there are some max students also. No, so I thought I'll conduct it in the morning, but there are some schools which are still working in the first week of May also. So it's better we'll have it in the evening itself. Yeah, apart from that, on 22nd, you have a test, you know that, right? So 22nd, you have test, prepare for that. You have any doubts, reach out to me. And did you all get the study materials? Everybody got it, right? Okay, make use of it. The study materials itself, after each topic, there will be practice problems. I'm not sure how many of you have gone through it properly. So in the practice problems itself, you have MCQs, you have the subjective questions, everything along with the solutions also. So it is completely solved book, and you have NCERT solutions, NCERT additional exercise solutions, exemplar solutions, everything is there. Only thing is sit and prepare properly. You have any doubt, reach out to me. Is that point clear? So anything else? Interesting? Yeah, the reason I'm telling this much is I'll be seeing you only after 10 days. Anything else? Yeah, one more thing is in the month of May, the first week of May, we are planning to do a workshop where it is not like, say, I am not sure if some of you would have attended previously, right? It would have been more of demonstrations. But this time, what I want to do is I want you guys to do it, which are related to your syllabus. In the sense, for example, like I'll be discussing a topic called as capacitor, right? I want you to do how a capacitor actually looks like. You can charge it, you can see the value of potential on it with a simple paper. Similarly, you would have learned about series and parallel connections, right? Have you ever done it parallelly, and has anyone connected parallelly and seen what will happen to the bulbs? So I want to do all these things. So electric charges, we don't have much. It's very simple, but I want to do mostly based on the devices and something related to light. Okay, so we have dropped the message in the group. So those who have seen, you can fill the form if you're interested. If not, just let me know. Okay, fill the form. I'll have a review of it and then decide when to conduct. Is the point clear? So, you have any other doubt, you can reach out to the official number. You have the official number, right, which is at the bottom. You will have it here also. That 93615 number. You can reach out for any other questions. Okay. So that's it. So yeah, we'll wind up. 22nd is Saturday, right? 22nd is Saturday. Okay. Then it's fine. Then you have to Sunday at least write it and upload the answers in the how do you say in the app and then let us know. But try to submit the hard copy here. You'll be going to school, right? Bring the hard copy, drop it here, but ensure you have already uploaded the answer sheet before you drop the answer. Is that clear? Yeah. Monday மட்டும் last. என்னாச்சு? அப்ப நீ ரெக்கார்டிங் பார்த்துக்க வேண்டியிருக்கும்.
ஃபர்ஸ்ட் நான் பிளான் பண்ணேன்னா ஃபீல் லைக் ஏன்னா நம்மளோட லாஸ்ட் மேபி லைக் ஸோ நான் இந்த ஹாஃப் அன் ஹவர் மிஸ் பண்ற மாதிரி இருக்காது இந்த ஹாஃப் அந்த லாஸ்ட் ஹாஃப் அன் ஹவர்
Little varied. Little varied. Video தான் பார்க்கணும். ஒரு எழுத முடியலையா? ஒரு எழுத முடியலையா? சரி, ஒன் மினிட்மா. லேப்டாப் வழியா பண்ண ஆப் தேவையில்ல, நெட் வழியா ஒரே ஒரு நிமிஷம். Just don't want to take a break. புரியல, ஒரே ஒரு நிமிஷம். ஒரு நிமிஷம்.